Good day everybody. Now I want to tell you about metal 3D printer. What is metal 3D printer? Everything you need to go from design to fully functional metal parts. The metal X3D printer system is end-to-end manufacturing solution. Manufacturing made easy. Our cloud-based 3D printer management software, built-in touchscreen interface and automatic material tracking make this Metal X system the simplest way to manufacturing metal parts. Now, I want to tell you about parts of Metal 3D printer. The first is ADAM, Atomic Diffusion Additive Manufacturing. At the intersection of 3D printing and metal injection molding, ADAM is an all-new way to build metal parts. Second, design. CD your part, upload the STL, and select from a wide range of metals. The Eiger software does the rest, making printing the right part easy. The third is part. Now, comprise only the pure metal. The final parts are ready for use. They can be processed and treated just like any other metal parts. The fourth is print. Metal powder bound in plastic is printed a layer at time into the shape of your part. Parts are scaled up to compensate for spring edge during the sintering process. The fifth is sinter. Printed parts go through washing steps to remove some of the binder. They are sintered in the furnace and the metal powder fuses into solid metal. Now the last is software. With automatic version control, real-time fleet management and cloud-based collaboration, Eiger is the world's most advanced 3D printing software. Designed from the ground to make manufacturing simpler, Eiger enables you to 3D print plastic, metal, and composite parts straight from your browser. Now, in the end of my video, I will give you what my company video, and the title is How Does 3D Printer Work? For your attention, I say thank you.
So the first step of our additive manufacturing process is 3D design. Our designer will either create a new design from scratch or take an existing design and improve it, add features that take advantage of 3D printing. We now have the capability of modeling our processes, so we can take these virtual designs and simulate our process in the computer, verify the designs are going to work as intended. So once we validate our 3D design, we will start by printing that in plastic. This is a relatively quick and inexpensive process that allows us to give us an actual 3D part versus a virtual design. We're in our additive manufacturing lab in Indianapolis, Indiana, next door to our powder facility where we make the atomized powders used in 3D printing. This printer has a 400-watt laser. A doctor blade carries the powder across the build plate. The laser then goes down and selectively melts or sinters the particles together to form a solid part. And then this process just builds layer by layer. A key advantage of additive manufacturing is the reduction in raw materials needed to process a part. Because only the powder that's needed for the design is used, the remaining powder is captured. And working with our powder facility, we can actually recertify these powders as needed for different industries. Once we have printed a part, either in plastic or more importantly in metal, we can scan the part and measure the dimensions and validate that we've met the criteria of our design. Additive manufacturing allows for complex parts that cannot be manufactured by traditional machining. This allows our customers to be very innovative. They can create designs that weren't possible in the past, and this can lead to improvements in efficiency, cost, and performance.